These are the Chapter 6 Notes 2 on rules for probability. Today we're going to talk about sample spaces, the multiplication counting principle, and some basic rules for probability. You might have noticed some pictures at the bottom of the page that denote some activities. For example, rolling one die. Think of some different things that could happen when you roll a die. For example, you could roll a 1, a 2, a 3, a 4, a 5, or a 6. These are the 6 different outcomes that could occur. You could consider groups of outcomes as well, like maybe you rolled an odd number, or maybe you rolled an even number. Maybe you rolled a number less than 4. We call any of these instances an event. Whether it be a single outcome, like rolling a 2, or a group or a set of outcomes, like rolling an odd number, this is an event. If you make a list of all of the outcomes, this is the sample space, the set of all possible outcomes. Let's look at some common sample spaces. For example, rolling one die. If you're rolling one die, the sample space is any single number that could come up. I just rolled a 3, but a 3 is just one of 6 different outcomes that could happen. You could roll a 3, you could roll a 1, a 2, a 3, 4, 5, or 6. Typically, when you write the sample space, because the sample space is the set of all possible outcomes, we also can kind of think of it as being a list of all possible outcomes, so we do want to list them all. And traditionally, what we do is we put little set brackets around it to show that it is a set. So, a sample space for rolling one die, what are the possible outcomes? Rolling 1, 2, 3, 4, 5, or 6. Now, if you're rolling 2 dice, there are a whole bunch of different outcomes. We talked about this as being an outcome last week, 2, 3. If the die on the left is a 2 and the die on the right is a 3, that would be one possible outcome. Of course, if the first die was a 3 and the second die was a 2, that's a different outcome. So altogether, there were 36 different outcomes, and we listed these last week. How would you write this out? Well, in some cases, if you have a whole lot of different outcomes that are out there, I don't know if it's entirely necessary to list them all. So what I might do is I might do something like 1, 1, 1, 2, 1, 3 in parentheses, ... And then kind of later on do comma, ... 6, 4, 6, 5, 6, 6. We'll use set brackets here. For rolling one die, we knew that there were 6 outcomes altogether. For rolling 2 dice, there was a total of 36 outcomes. Choosing a card. Now, when you're choosing a card, we know there's a whole bunch of different outcomes that are possible. Here's our deck of cards. Flip one over, King of Spades. That is one possible outcome. Now, in a standard deck of cards, if you have a 52 card deck, obviously there are 52 different outcomes. Again, I don't find it necessary to list them all, especially if there's a large number of them, but I might do something like Ace of Diamonds, Ace of Spades, Ace of Hearts, Ace of Clubs, and then continue with the King of Diamonds. And I'm just going to do a ... because you can kind of picture where that's going to go. King of Spades, King of Hearts, King of Clubs, Queens, Jacks, 10s, 9, 8, 7, 6, 5, 4, 3, all the way down to 2. So I might show that last set, the 2 of Diamonds, 2 of Spades, 2 of Hearts, and 2 of Clubs. And altogether, there were 52 outcomes. This is usually from a standard deck. If you're including the jokers, you'd have more outcomes, obviously. Flipping coins. You know when you flip a coin, 2 outcomes, heads or tails. What if it lands on its edge? We're going to assume that never happens. I know in theory, I guess it could happen, but we're just going to assume traditionally that heads and tails are your 2 outcomes. I'll abbreviate them H and T, and there are 2 outcomes possible. When you flip 2 coins, Here we have tails, heads. That is one possible outcome. Now, if the first coin was a head and the second coin was a tail, that would be a different outcome. When flipping two coins, you're probably aware that there are four possible outcomes that are available to us. HH, HT, TH, and TT, and that would be considered four outcomes. If we add one more coin to the mix and flip three coins altogether, at first glance a lot of people think, oh, that would be six possible outcomes. So here's one possible outcome, heads, heads, tails. Now, if you consider, if we start with two heads, you could go heads, 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 or heads, heads, tails. If you started with heads first and tails second, the third coin could be either heads or tails. So you could have heads, tails, heads, or heads, tails, tails. If the first coin was a tail and the second coin was a head, you could have tails, heads, heads, or tails, heads, tails. And if the first two coins were tails, tails, the third coin could be either heads or tails. And this altogether doesn't give you six outcomes. It gives you a total of 8 possible outcomes. Listing them all and separating them with commas is typically how you write your sample space. Of course, one other thing you could do is you could combine implements. For example, you could flip a coin and roll a die. What would that look like if you're writing the sample space? Well, here's a coin flip. Here's a roll of the die. We got tails and a 5. So we abbreviated tails with a T. 5 is 5. So T5 would be one possible combination that would be out there. There's a bunch, in fact. If you start with heads first, you could go heads with a 1, heads with a 2, all the way up to heads with a 6. And then similarly, if you flip a tail first, you could roll a die with a 1, 2, 3, 4, 5, or 6 in it. Now, one question you might ask is, well, could you flip them around? Could you say 1H and 2H? Would that be something different? Because it says flip a coin and roll a die, we're kind of assuming that what's going on is you're starting with flipping a coin first. So the first value is a coin toss option, and then the second value is a die roll option. When you count the total number of items in this set, it looks like we have 12 outcomes altogether. So these are examples of some different sample spaces that you could possibly work with. Now, what you may have noticed is that for flipping two coins, there were 4 outcomes. It's sort of like there were 2 options for coins, coin 1, and 2 options for coin 2. 2 times 2 is 4. Or for flipping 3 coins, there were 2 options for the first coin, 2 for the second, and 2 for the third. And if you multiply these numbers together, you get 8. Or 2 options for the coin flip, 6 for the dice roll, 2 times 6 is 12. This idea of multiplication to find the number of outcomes is known as the multiplication counting principle, or the multiplication principle. And it says if task 1 can be done A ways and task 2 can be done B ways, then both tasks can be done A times B ways. This multiplication principle can be very helpful in a number of different contexts. Let's look at license plates, for example. Here we have a license plate that starts with 3 letters followed by 4 numbers. And the question says how many different arrangements of license plates can be created with 3 letters followed by 4 numbers with replacement. The idea of with replacement means that repeats are okay. So replacements means that we can repeat numbers, and that's okay. Or letters as well. So if you start with 3 letters, there are 26 letters of the alphabet, so you could choose any of 26 letters for either of these first 3 characters. Then for digits, for numbers, you could use the numbers 0 through 9. There's 10 numbers there altogether, so for each number, you have your choice of 10 different digits to choose from. So we're going to be multiplying 26 3 times 10 to the 4th power and getting a value there. For 3 letters followed by 4 numbers without replacement, that means repeats are bad. We don't want to repeat any characters. So you have 26 choices for the first letter, but if we choose, for example, the letter C, we can't use it for the second letter. That gives us just 25 letters to choose from. If we choose an F for the second letter, for the third letter, we can't choose C or F. That gives us only 24 letters to choose from. For the same idea for numbers, you would have 10 different numbers to choose from. Let's say you pick the 7 first. But then for the second number, you can't pick 7. You got to pick something else. There's 9 numbers left to choose from. If you pick a 3, we can't pick a 7 or 3. That gives us 8 numbers to choose from. Let's say we choose a 6. And then for the last digit, because we can't choose 7, 3, or 6, we have 7 numbers that we can choose from. Now, what if you have a license plate that starts with 2 letters followed by 3 numbers? With replacement, for 2 letters, first 2 letters can be anything. You can repeat them, so you have 26 choices for each letter. For your 3 numbers, 10 times 10 times 10. 10 choices for the first digit. You could choose any of those same 10 digits for the second digit or for the third digit. For 2 letters followed by 3 numbers without replacement means repeats are bad. So you have 26 letters for the first letter. If you choose an A, can't choose it for the second letter. That gives you 25 for the second choice. For your numbers, 10 choices for the first number. If you pick one, that gives you 9 numbers left to choose from for the second number. And if you pick a different number there, that gives you 8 numbers to pick from for the third number. If this was a homework assignment, I'd also expect you to crunch out what this is equal to, but I do expect you to show this work as well. What about playing cards? How many different ways can 2 playing cards from a deck of 52 cards be chosen with replacement? The idea of with replacement means is if you have a deck of cards, let's say you pick a card, it's the King of Spades, that's great. Put it back in the deck, shuffle it up again. If you draw the same card again, that's fine. So with replacement means you can draw the same card both times. There are 52 possible options for the first card, and there are 52 possible choices for the second card. This is the number of ways that 2 different playing cards can be chosen from a deck. And they don't have to necessarily be different. They could be 2 of the same cards. Without replacement means there are 52 cards to choose from for the first card, but don't allow repeats. Take this King of Spades, it gets thrown out of the deck here. The next card we draw is going to be something other than the King of Spades. And of that, there are 51 cards left. Again, on your homework assignment, I would expect to see the work as well as what the final answer is equal to. So we wrap up today with some basic probability rules. We'll talk more about probability in the upcoming days, but some basic things that you should know about probability. First of all, when you see the notation P of A, this is referring to the probability of event A happening. The capital P stands for probability. A is the event that's occurring. Probability rule number 1 says the probability of an event happening has to be between 0 and 1. And it does include the numbers 0 and 1. The S in this problem stands for sample space. The probability of all the events in the sample space is equal to 1. So probabilities consist of everything that is in the sample space. So the probabilities of all the events in the sample space add up to 1 or 100%. Rule number 3. The probability of A, this little c stands for complement, is equal to 1 minus the probability of A. A complement is another way of saying not A. The probability of A not happening is 1 minus the probability of A happening. So another way of thinking about this is if there's a 60% chance of something happening, the probability of it not happening is 1 minus 60% or 40%. Our final rule is the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. Or in this case can be abbreviated with this U symbol, which we talked about in other classes, which stands for union. Or means A, B, or both A and B. So don't think of or as being either this one or this one. Or could mean both events as well. These are some basic rules in probability, and you could use those probability rules to answer questions like the ones below. On this chart, we have a distribution of global scores for the 2015 AP Statistics exam. The score for 5 is missing here, and the question asked is what's the probability of a student earning a 5? You could probably figure that out because you know from Rule 2, all the probabilities should add up to 1. For Rule 4, what's the probability that a student scored a 3, 4, or 5? Well, that would be the probability of students earning a 3, plus students who earn a 4, plus students who earn a 5, as well as anybody that earned both scores. Well, since that's impossible, all you have to do for step 4 is add these probabilities together. See if you can do these 2 problems, check your answer with your teacher, and that should give you a pretty good understanding of how basic probabilities and sample spaces work.